Custom Metal Fabbers, this is Mr. Schulte. Hey, I wanted to introduce to you the repair project. It's the first project we're going to do in the class. And I've got a repair project of my own that I'm working on here. I'm in my own shop and I've got a buddy's boat here that's got a tiller handle issue. And the repair is not really a weldment repair. It's more of a machining and some boring and replacing of components. So I'm going to go over what I've found out so far right now. The major issue here was this tiller arm had a lot of play in it, so that the tiller would basically move back and forth in this hole without actually moving the motor. And you can see that it's gotten so bad that it's actually oblonged the hole. See if I can get it to focus here. There we go. And the hole is now oversized from the bolt that goes in there. And if I show you that bolt as well, we got quite a bit of play. Now there was a plastic bushing in there, and this would be a plastic bushing or sleeve, but you can see it's worn through, actually worn through on one side, and it's worn down quite a bit in diameter. So, you know, not America. Putting plastic in there, bad idea. So the plan for this, I've taken some measurements, and the plan is to basically replace that plastic bushing by drilling out this hole and oversizing it and then making a sleeve out of brass. So I'll be turning this on the lathe down to the diameter that I need to fit inside there, and then I'll also have to drill the center of that out to match the bolt that goes in, because the bolt will actually go in through this hole, and then there's threads on this side. Not sure if you can see those or not in there, but it threads in tight on the other side. It'll also need some spacers. You can see a recess right there, and that'll need to be spaced out. And there are washers that fit in there, but I'll probably have to build this out a little bit because the width right there is about 120 thousandths larger than my width right there. And if I put these two in, you can see there's quite a bit of room there. So we need to basically take that up with shim materials. So here's really hopefully all I need for information. This is my sketch. I've got OD and ID, which is outside diameter and inside diameter for the washers. And I've got the wear hole that goes through the tiller arm, and it's oblong, so it's anywhere from 524 thousandths down to 496. So it's over a half an inch, which is kind of a pain because conventional drill bits go up to a half, and then I'm going to have to kind of search for something that I can chuck in a drill. I'm doing this all portably. Ideally, I would take the tiller handle out of the boat and set it up in a drill press or something like that, but that's not going to happen. I'm not going to unwire everything. And then this is my tiller arm and just my two measurements there. So you can see my variable would be, doing the math, 167 thousandths, something like that. So just over 1/8 of an inch of play between those two pieces. So next video we'll just go over setting up this piece in the lathe and actually machining those bushings.